Good morning or good afternoon, everybody. It depends where you live, where you are. Thanks so much for joining me in this presentation. I'm Giorgio Natili, and today we're going to talk about engineering, requirements, reliability, and resiliency. Our agenda is pretty simple. We'll start with some definitions of what is system reliability, for instance. What are, in essence, system requirements? How we validate them, how we dissect them, and how we manage requirement conflicts. All of this is to build into our requirements the resiliency and reliability that is needed for modern systems. Let's start. Let's talk about systems reliability. Systems reliability, it's a very wide topic, but in a nutshell, it is the data point that make your system available and reliable for other systems. So it's very close to what is availability. It is also the ability of a system to function under very difficult conditions or stated conditions for a specific amount of time. Imagine if one server is going down, a node is going down, your entire cluster is going down, or just some dependencies. It is the result, from a numeric perspective, of the product of the reliability of each component of a system. The more components, the more they are reliable, the more reliable is the overall system. How to measure reliability? Of course, it's done through the components that belong to your system. The reliability, most likely, it's characterized by its failure rate, and it's proportional to the parallelization of a system. In fact, if you look at series and parallel systems, you can see that in the context of A, it's very likely that if 2 fails, everything else stops. Everything that is after 2 will stop. In a system that has a high level of parallelization, like B, if 2 fails, it's not granted that the system will fail. Reliability can be achieved with several techniques, but the most important thing is that should be assessed. To assess reliability, you need to provide a set of quantitative evidences that the system component is not creating any unacceptable risk. For instance, if your storage goes down, what is the redundancy that you're offering? If your service is going down, how much time is it required to spin up a new instance of your service to bring back everything online? During the assessment of the reliability of a system, you produce artifacts. These artifacts are reliability block diagrams, hazard analysis, failure mode analysis, and effect analysis. For instance, what is the effect if the system goes down on the overall systems that you manage or that your company owns? What about if it's only a service? It's still a system, right? And if it's still a system, what is the effect if this system goes down? What are the recovery or retry strategies of the other components? These are the kind of artifacts that you produce during the reliability allocation, reliability assessment phase. It's identifying hazards that can impact your system that you build reliability into your architecture. And it's identifying mitigations that you can lower or enhance the reliability of your system. The reliability allocation can be extremely different accordingly to how you distribute it. Can be divided and allocated equally, focusedly, or by availability. The difference is that when you do an equal apportionment of your reliability, you distribute the reliability among all the components of a system. No matter what, no matter how, each of them owns a specific amount of reliability. When you are doing a focused apportionment of your reliability, you concentrate the reliability on critical components. It's a strategy, right? You cannot most of the time achieve the same level of reliability, but if there are core services that belong to your system, that's where you want to focus and concentrate your effort. When you decide to do an achievability apportionment of the reliability, you concentrate the reliability on the components that can achieve a higher reliability. Let's say that you have a system that has 3 services. One is really easy to make 99.9 reliable, while you focus your attention over there, and the others still can contribute to the overall reliability, but will have a less impact. What is the relationship between reliability and requirements? Why they are so connected? Why they are so important? Requirements are essential to build reliable systems, because what is reliable for you should matter to the other stakeholders and to your customers. It's only through clear requirements that you can get to that. The clarity of system goals, it's another key component and contributes to the system reliability, because it's through the goals that you can define thresholds that will, when applied, will make a difference between a reliable or unreliable system. Stress test, chaos testing, chaos engineering, all of this can be better tailored if you have very clear goals. You build reliability into your systems through requirements that can be validated iteratively through a dissection and analysis that is continuous. What is a system requirement? A system requirement is nothing more than the essence of a desired change to a system that must be defined precisely and concisely. Apologies, I used must and I wrote should. In the ideal world, every single requirement must be precise and concise. In reality, they're not like that. That's why we're here today, because we want to understand how we can change the way we define our requirements, and we make our contribution as engineers to our requirements to build concise, precise requirements that can help us to understand how our system is working. We have obviously different level of requirements, and many of them are high level, many of them are low level. But overall, there are requirements that influence the availability, the efficiency, the integrity, the robustness, the reliability, the interoperability, and the testability of your systems. Also, there are requirements that influence the flexibility of your system, and all of them, all together, are what you need in order to define precisely what your system is going to do. Requirements have different dimensions. The main dimensions that I usually apply are content, documentation, data, performance, reliability, and security. As you can probably easily understand, performance, reliability, and security are what matters the most to build reliability into your requirements. But at the same time, the content, the documentation, and the data that you use to build your requirements are essential. If you have input data that are not aligned or that are incorrect, whatever you want to build from a reliability perspective can be biased. If the content, if the definition of a goal, of a requirement, it's not clear, you cannot build anything that has a reliability that really matters to stakeholders and customers. It's through these dimensions that you can have a dissection of your requirements and an understanding of how these requirements are really performing into your system. Yes, requirements have performances. Every time that the requirements it's generating a defect, it's clearly performing lowly. So you should track that and bucket the defect accordingly to these dimensions. Feel free in your domain, in your company, in your space, to add additional dimensions. But these are the 6 that you can use as a starting point. At the end of the day, no matter what, requirements represent your fastest path to understand what the system must do. And along the way are the tools that you should use to have an even deeper understanding of what the system under development is supposed to do. Why is that? Is that because you can understand other personal intentions through clear requirements? Requirements are rarely clear. And that's why we need to start to validate our requirements. There are several techniques to validate the requirements. For instance, you can use checklist. A checklist is nothing more than a set of standard questions that you can define and that you want that your stakeholders, your engineers, your QA engineers, your technical program managers, your agile developer leads, whatever is the stakeholders, use when they're building a requirement for you. The checklist is nothing more than a tool to drive the thought process of others and to avoid common mistakes. Another validation technique is having a document-based review of your requirements. For instance, you can develop your requirements as a PR FAQ, and you can understand how your product can perform and how your product will be seen from others. You can have a document that describes the overall architecture. You can have a document that describes your trade-off analysis to achieve a specific goal in a specific amount of time. All these requirements, all these kind of documents can help you to validate your requirements. Other 2 tools that you can use, it's having an in-depth discussion with, of course, question and answer with your requirement reviewers, and what I call decision records that are nothing more than changes that can happen to requirement when you discuss them that align more stakeholders. It's important when you review your requirements that you involve the requirement reviewers that you feel them are the more appropriate. You can have domain experts, you can have architecture, you can have QA, you can have external reviewers, you can have also moderators. It's very challenging to keep a conversation about requirements on track and focused. So usually having a moderator that is external to the group that is debating the requirement, it's really helpful and impactful. When you want to validate, it's another point that you should evaluate and assess in your organization. Overall, I see 3 main moments. One, it's an offline checklist. Basically, you can provide your requirements writers, your stakeholders, with checklist and templates, and your business analysts, your stakeholders, can simply use that to come out with the requirements that meet a minimum bar that you want to apply. Then I would move to online. And online, what I mean, it's face-to-face conversation, no matter if they are remote or in the same meeting room, where you deep dive on the requirements, where you try to understand if your requirements are really representing completely and exhaustively the product that you are building. Even more, your requirements should provide you the data point that you need to make a system reliable. Requirements can be in any form, can be user story, can be business requirement documents, can be anything. The important thing is that when you do the deep dives, you select the right SMEs, the right people, and you really dig into it until you don't find a common understanding of what you're going to build. Another important area that you should assess your requirement for, it's how the requirements align against OKRs and technical constraints that your organization can apply. Let's talk about the first tool, checklist. Checklist should be small and concise. The reason why it's because a very long checklist tend to be destructive and tend to prevent other engineers to add items to the checklist and therefore limit the creativity of your group. Build asynchronous and synchronous checklist. There are checklists that can be executed in isolation. And this is a great way to save time. And time is really the only thing we cannot control. Try to leverage closed-ended questions to prevent debate happening during the completion of a checklist and to guide the thought process of others. Make them expandable. Make them editable. Encourage contribution, because it's through others' contribution that you can achieve a checklist that will really cover what is needed from your systems and from your work. A very simple checklist, it's, for instance, which are the production pipelines? What are the stress test environments? What are the results? If chaos testing has been applied? What is the impact of the outage of a system? What are the availability and retry metrics of each service of a system? How the system or the software it's handling critical data? What are the dependencies, latency metrics, and how they impact your latency? To make the checklist extremely engaging, you should have a very iterative process. Any improvement that you want to make, or that your partners, that your engineers, that your team want to make, should be data-driven. For instance, you can track requirements defect rate and understand if your checklists are really mitigating the issue or not. Remember that moderated discussions are the best tool to come to a conclusion with a third party that is not involved too much into a specific project, but have an understanding of the systems that are involved. This is a very engaging technique where you can have live discussions, arguments, and opinions that are shared all together. Requirement validation can be extremely costly. To mitigate the cost, try to make it structured and not a free form. Identify always the goals that you want to achieve. Identify when you should stop to dig into a situation or into a discussion and step back. Time frame your validation in order to try to achieve the best you can in a very specific amount of time. But don't let the time framing kill yourself. A time framed discussion can bring you to incompleteness. Validation must be just enough to build something else or to build some part of the system and learn from that. Leverage your tech leads. The tech leads has the better understanding of the system, and they do understand when it's enough to stop digging into a specific problem. One of the techniques that you can use is to dissect your requirements. The requirements get dissected in 3 specific phases during the elicitation of the requirements, negotiation, and documentation. When in requirement engineering, requirement elicitation is the practice of researching and discovering the requirements of a system from users, customers, and other stakeholders. This practice, it's also referred sometimes as requirement gathering. You can really start with very few requirements, and then through focused question, drive this conversation, gather the data that you need, and build your requirements. The importance of focused question, it's very huge. Asking questions trigger conversations and set up and pose any confrontation. Questions generate a backlog of discussions that are open when you are dissecting your requirements and you are trying to understand what are the constraints that build the reliability of your system. Generic questions cannot address specific requirements, so skip them, avoid them. It doesn't matter if you are asking how this is impacting my customers, if you're talking about a system that is doing a backup. It's a generic question. And be specific. Be specific from a context perspective. And imagine that there are areas where you can create a question bank that help you to improve the reliability and the resiliency of your system. For instance, ask yourself questions, or ask during the sessions when you dissect your requirements, questions like, what is the resilience to failure of each of the components of the system? How is it possible to deploy the configuration to different stages? And how is it possible, and if it is possible, to increase TPS load without making a new deployment? All these questions will help you to understand where are the resiliency gaps in your system. From a reliability perspective, you can use different questions. You can ask yourself, what are the single point of failure of the system? What is the retry back-off strategy for each of your dependencies? Imagine you're consuming a service that is external, is not under your control. What is your retry strategy? Twice, 3 times? What is the back-off strategy? How you move back from that services, from that dependency, and how you create a reliability without having control of all the components that are part of your systems. Questions like that can help you to create question banks. Question banks come from experience and learning. So don't be surprised. At the very beginning, you will have very few questions. It's expected. You will build up your questions accordingly to your needs and to the learning that your systems will generate. You will have the opportunity to iterate and experiment with new questions and see what happened in a meeting, what happened in a discussion. The question bank, it's a tool that will help a lot of your engineers and team members to start asking questions, because it's not always so easy to start asking questions. Review and suppress questions that are not adding any value. All these questions are nothing more than your negotiation phase. When you negotiate a requirement, you are talking about the requirement and you are exploring different perspectives and different point of views. During the negotiation, you are able to identify conflicts between requirements, milestones, and core stakeholders. For instance, if a stakeholder has a specific threshold for the latency and you have a different one, that's clearly a conflict. But you can also use this as an opportunity to identify milestones and reach maybe the desired latency in multiple releases. Or if it's not achievable, you can have a conflict resolution. Documentation, it's another important phase of your dissection analysis. And by that, you need to update any functional requirement. You need to update the non-functional requirements, and you must create a backlog of follow-ups. A backlog of follow-ups can be anything that is like a spreadsheet, a Jira ticket, a quip file, whatever. Doesn't matter which word you are, you can have a simple backlog of follow-ups. And you can also start to understand what are the red, yellow areas of your systems or the systems that is under discussion. For instance, a red area can be that you don't have enough alarms. A yellow can be that the cache behavior, it's not yet verified. All of this should be documented and should be the drivers of prioritization of your next discussion. When you want to write, when you want to go deep on a specific area, on a specific topic, I recommend to use documents and to write down your thought process. Documents doesn't need to be 10 pages. Actually, try to stay in 1 page if possible. Give a background. Describe what is your proposed solution and why do you feel that it works. Be self-critical and show that you considered alternatives and why they failed, at least in your perspective and in your design. Identify the risks and the assumptions that you're making in proposing this solution, and come out with a conclusion. A concise document like this can drive a conversation and can keep the conversation really on track. Whenever you come with a conclusion, well, start to have a document that describes your decision. Doesn't need to be a one-pager. Should be just a few lines. What was the issue? What has been the decision? What is the decision status, just in case it's still pending some validation? What are the assumptions and the tenets of your system or of your organization that helped out to make this decision? Link to the document that helped you to make the decision, and this will be your track of records that will help you to go back in time whenever you have to reassess a decision. The expected outcome of the dissection are requirements that get updated, a set of negotiation outcomes that are nothing more than decision record documents, and deep dives. Deep dives can be on open questions, can be on tech decisions. In any case, sometimes are not omnicomprehensive. So you should have a list of open conflicts that still have to be resolved. What is a requirement conflict? A requirement conflict is when two stakeholders have a different point of view and doesn't have an agreement. How it's possible to identify conflicts? You can identify conflicts simply by exploring your guidelines and understanding why and when something is in conflict with your guidelines. You can identify the root cause. And you can imagine and actually explore how a requirement is diverging from a guideline and it's impacting your customers. This is another typical case of conflicts. And how a requirement is impacting the system. Because if you have a requirement that ask you to have a real-time data streaming, that's impacting the system. So identify your conflicts and ask yourself when conflict arises. Most of the times during the elicitation, prioritization, validation, and resolution of a conflict. Don't be surprised. When you solve the conflict, new conflicts can arise. It's part of our mission as engineers to hold ourselves accountable for the quality of the requirements that we're building. Therefore, if a conflict arises, if a new conflict arises, please, let's welcome it, because it means that you are digging into your requirements and you're building reliability into your own requirements. There are several techniques to manage conflicts. An early conflict management techniques is to use project goals to disambiguate. So if the project goals is to be real time, well, there is no point of having asynchronous calls. Or it can be assessed with different data points and understand what are the thresholds that you should apply. You can leverage your team tenets and organization tenets and understand, for instance, if for you it's mandatory to be 99.9% up, well, that's easy to disambiguate any conflict around reliability and availability of your system. You can identify if a conflict is not needed to be solved now, and you can check if a conflict is arising because of misinformation. It's very likely that this is going to happen. You should classify your conflicts to better understand where your requirements need to be improved. The four main buckets that I use to classify my conflicts are around data, value, behaviors, and architecture. Of course, data are lack of information, threshold analysis that are partial or outdated. Value, some stakeholders may value different attributes in the system, reliability versus resiliency, or reliability versus availability. From a behavioral standpoint, stakeholders can have different behaviors as critical, and therefore they can create conflict around what is their prioritization and what is their vision for the next step for your system. There are different architectures that sometimes don't integrate well. This can create other conflicts. You resolve your conflicts through negotiation, creativity, and escalation. Negotiation, it's leveraging the tools that we discussed, documents, conversations, architectural diagrams, and you exchange this information to be sure that every party involved into the discussion is aware of what is the meaning of a specific requirement. Creativity. Don't be afraid when you have option 1, 2, and 3 on the table. Come out with option 4. Everyone bring their own option, and everyone is emotionally attached to their option. When you're able to identify a different one that is a different viewpoint, then you will likely to succeed on your conflicts. You can also escalate. Escalation is a good tool, can be used. It's not a problem. It's not a punishment. The only drawback of escalation is that when you escalate for a decision to an higher level, like a senior director or VP, well, then you are demotivating others, because whoever proposal is not picked, it's discarded, and there are not too many conversations. And this usually it's the last tool that I would recommend. Okay. So let's recap what we discussed so far. We discovered how we can move from checklist to discussion, and how discussion are a tool to identify areas of conflicts, and how documents make clear, crisp, what are the thought processes around your requirement and your system, and how these can be different or similar to the needs of every stakeholders into your project. We learned also how decision record documents contribute to clarify the motivation of a change and why they are important. We discussed how to manage confrontation, leveraging question, trigger curiosity, leveraging open-ended question to understand the depth of a thought around a specific requirement. Identify alternative solutions as a tool to mitigate any of the conflicts that are around your systems and your requirements. Document the thought process to prevent misinformation. We also discussed how much it's important to understand your constraints. Use always data and understand through data what are the real reliability requirements of a system. Acknowledge that every system is unique and deserves deep understanding of constraints. Develop reliability into your checklist and validation techniques to be sure that since day one, your system is talking about reliability from the conception to the implementation. Well, thanks so much for your time. I hope that you enjoyed this presentation. Please follow up for any question on Twitter, and have a fantastic rest of your day.
Hey, it's Joe Eames with ng-conf. If you like that video, be sure to click subscribe either here or here, somewhere over here. And if you're looking for something more, here's another video for you to watch here or there or somewhere.